Now, in this video I'm going to prove if y is equal to log x, then dy upon dx is equal to 1 upon x by first principle. So, let y is equal to log x. Let it be equation number 1. Now let delta x be the increment in x and delta y be the corresponding increment in y then equation 1 becomes y plus delta y is equal to log x plus delta x. Now transposing y to right hand side, we have delta y is equal to log x plus delta x minus y. Now substituting y is equal to log x from equation number 1. In this equation we get delta y is equal to log x plus delta x minus log x. So as we know that log m minus log n is equal to log m upon n. So this may be written as log x plus delta x upon x. Now splitting this fraction, we may write it as log 1 plus delta x upon x. Now multiplying and dividing by delta x upon x into 1 upon delta x upon x log 1 plus delta x upon x. By logarithmic property, the coefficient of log goes in the power of this bracket. So we have delta x upon x log 1 plus delta x upon x raised to the power 1 upon delta x upon x. Now dividing both sides by delta x, we get del y upon del x is equal to, if we divide y delta x from the denominator, we'll cancel the delta x from the numerator and we have only 1 upon x, and log 1 plus delta x upon x raised to the power 1 upon delta x upon x. Now taking limits on both sides, limit delta x tends to 0, del y upon del x is equal to limit del x tends to 0, 1 upon x log 1 plus del x upon x raised to the power 1 upon del x upon x. As we know, by standard limit, limit x tends to 0, 1 plus x raised to the power 1 upon x is equal to e, that is exponential coefficient. So by differential calculus, limit delta x tends to 0 del y upon del x is denoted by dy upon dx is equal to and 1 upon x as it is, and applying this limit in this we get log e, because this expression has the same framework as this one, 1 plus delta x upon x raised to the power the reciprocal of this, here the same 1 plus x and raised to the power reciprocal of this, and that is equal to e by standard limit. So this expression becomes e by using this limit. So we have log e, and obviously log e is equal to 1. So we have dy upon dx is equal to 1 upon x. So the derivative of log x is 1 upon x, and here it is the proof of this standard result.